So for section 7.3, we're going to be looking at least common denominators. It's, once again, kind of a review topic. They're prepping you for the rest of chapter 7, where we're going to be adding and subtracting rational expressions. And to do that, they're going to need common denominators, just like when we add any fractions, okay? So they spend one section just doing least common denominators. But basically what we're going to do is I'm going to just start with these first two. Okay, the 7x squared and the 5x. When I want a least common denominator, I'm going to start with the least common denominator of those numbers, 7 and 5. A lot of you are already going, yeah, 35, you've done this enough, you're kind of comfortable with it. But if you're not sure, to find the least common denominator, you can count by or list multiples of those numbers. So if I say list multiples, there we go, then I'm counting by that number. So 7, 14, 21, 28, 35, 42, so on and so forth. And I can list multiples of 5, 10, 15, 20, 25, 30, 35. And the idea is I want the least common multiple that they have. I want a number they could both become. Well, yeah, they could both become 35. Now that gets a little tedious, especially when the numbers get a little bigger. So we're probably not counting by both those numbers. What you would do is just take the larger number, just take the 7, and count by 7s. You could even do that in your head. 7, 14, 21, 28, 35, 42. Just add 7s and stop when you get something 5 goes into. So there you go, 35. Why would I do that with the largest number? Well, because it gets there faster. 5 took 7 spots to get there, 7 took 5 spots. So I'd start with the largest number, kind of count by that, and stop when you find one that they both go into. Alright, so our least common denominator here is going to start with a 35. That's the least common denominator of the numbers. Now, what about the highest power of each term? Well, what I'm left with is these terms, x squared and x. The x squared is basically what? 2x's, and this one only has 1. I'm not trying to find how many they have in common. I'm saying if I was going to make them the same through multiplying, what would be the amount that I would need to make them both? Well, x squared. Don't multiply them by each other, just keep the highest power. We have an x squared, we have an x to the first, so our least common denominator would be x squared. Last is this kind of group over here, 5x plus 1. Well, what else does this need? Right? This 5x is not an x by itself. This is not a 5 by itself. What this is it's its own group. And it is not in either of the other ones. So when you have a group like that, we'll keep the highest power of that individual group. So our least common denominator will also need that group. So it's the highest power of the numbers, the highest power of the term x, and then any groups we keep individually. This 5x is different than this 5x. Remember, this one is a group with the 5x plus 1, and this one is just a 5 times x. I expect this to be a little frustrating, a little confusing at this point. If you're like, no, I think I could do this, then you're in good shape. But if you're struggling, I'm going to kind of show you how this applies. The questions are just going to look like this. They're going to give you these two and say, what's the least common denominator? Okay. What I want you to think of it is, if these were two fractions, two denominators, and I was trying to add them, what would be the lowest denominator I could make them both? That's what we're really doing. Once again, the questions will look, well, basically like this. And they'll say, what's the LCD? But what I want you to think of is, okay, if I were adding, if I were subtracting, what would be the lowest common denominator for these? Start with the numbers, 12 and 18. I recommended counting by 18s. Add 18s. 18, 36, 54, 60, 72. And feel free to use a calculator with this. You literally could just keep adding 18, adding 18. I want something that 12 goes into. Do 18 divided by 12. Nope. 36 divided by 12. Yep. That is the lowest common denominator of the numbers. I could make them both a 36. What about the x's? Keep the highest power, x and x squared, so they would both be an x squared. So now I could technically make them both the same. I could add those fractions. That's the next section. For now, you're just finding the least common denominator. Next. Once again, I've kind of set it up to show you if I had two fractions and I was adding, subtracting, multiplying. Sometimes, though, they'll just put the question like this. I think this book might actually do it a little better. The old book that we used would just give you this and go, what's the LCD? I was like, that's a little frustrating. So think of it as, if I had two fractions and I wanted to add or subtract them, what would be the lowest common denominator? Well, this is a 15y squared, 3y squared minus 6y. It's tempting just to go, they don't look anything the same, just multiply them by each other. Keep in mind, you have to check if anything can factor. 15y squared doesn't factor, but 3y squared minus 6y, yep, we can pull out from that both a 3 and a y, leaving us with y minus 2. What does that do for us now? I can start with the numbers, 3 and 15. Lowest common denominator of 3 and 15 is 15. Lowest common denominator for y and y squared. Keep the highest power. And what do I do with that group at the end? Well, if I wanted to add these, they would both need that group. So it would be part of the least common denominator. Let's do one more, and then I think we're going to kick it up to something else that I think is interesting, but not a basket here. Okay? Three fractions. Least common denominator. You're like, well, they all have a z squared. No, they don't. Remember, I'm looking for things that are multiplying. They're not factored. You have to do that first. So, like technically I see they all have a z squared, but I need them to be groups that are multiplying that are the same. Okay? So I have z, how about plus 4 and minus 3? Makes a negative 12, combines to make a positive 1. This is an a squared minus b squared, so z minus 3, z plus 3. And this one, how about z and z? We're looking at 4 and 3 to make a 7. So this time it's all groups. So my LCD is not like an LCD of the numbers, an LCD of a variable by itself. We need to figure out, well, what groups do we need? Well, this has a z plus 4, this one doesn't, this one does. So our least common denominator will be not z plus 4 squared. I understand these both have 2, but they don't need to. We keep the highest power of that group, which is just z plus 4. If one of these was z plus 4 squared, then I would need a 2 down here. Okay? Next group I see, how about z minus 3? And what? Not squared. We only need the highest power of that, so z minus 3. And our last group, and what color am I on? Yellow, is the z plus 3. So now if I were adding these fractions, I could just give each one what it needed to become a like denominator. This is not on the test, but there are a couple of these in the homework. I think they're interesting because they get us thinking about equivalent fractions and changing denominators. So I do leave this in the homework, but I will not test you on this. It really is prepping you for a skill that we're going to be using. Okay? So how does 17 over 3y minus 4 turn into something over 24y cubed minus 32y squared? Okay, well, these denominators are not the same. Could we make them the same? How could I turn 3y minus 4 into 24y cubed minus 32y squared? It's hard to compare them with them the way they are, so we factor the denominators. This 24 and 32 are both divisible by, I think, 8, and they both share 2 y's. What does that leave us with? 3y minus 4. So really that 24y cubed minus 32y squared is just 3y minus 4 times 8y squared. So these two fractions would be equivalent, oh, my handwriting stinks there, EQUI, there we go, equivalent if this right here got a 8y squared. Now the denominators would be the same. But you cannot just multiply the bottom by an 8y squared. What would we have to do to the top? Well, we'd also have to multiply it by 8y squared. So what does the top become? 17 times 8, about 80 plus 56 is 136 y squared. And that would be the answer. That would be the number that makes the two fractions equivalent. Factor the denominator, find out how it changed, change both the top and the bottom to show what the top becomes. It's a little confusing, but trust me, there is a skill here that I am wanting you to kind of see. Won't test you on it, but just something, if you're struggling with it, come see me. Go to the Learning Center, lots of resources. 3 times, I don't think I want that there, sorry. This is just, and this will be, I think, our last example. Let me make sure I'm not lying to you. Yep, this will be our last example, and I like because it kind of kicks up the factoring a notch. This is 3 over z squared minus 16. Well, what is that really? 3 over, how about z minus 4, z plus 4. So I want to make an equivalent fraction. This is a whole mess. How do you factor this? I'll give you a hint. How many terms are there? 1, 2, 3, 4. Have that note card from the last test. When there's 4 terms, factor by grouping. First 2 have what in common? Leaves us with. Second ones have what in common? Leaves us with. So what do we have? Well, a z plus 1 and z squared minus 16. The z squared minus 16 factors further. So now, these two denominators have this in common. What did I do to change the fraction? I multiplied it by this piece. This fraction over here doesn't have that piece. So what I will do is multiply the top and the bottom by what it's missing, which is the z plus 1 on the bottom and the top. That makes the bottoms the same, and it makes the top 3z plus 3. And that is the answer you'd put in for the homework. A bit challenging, I get it, but this is really just some skills that are prepping you for the end of the chapter. If you're solid on 7.1 through 7.3, 7.4, not that much harder, 7.5, 7.6, I think actually the solving some of the easiest stuff we do. So good luck, we're almost halfway through the chapter, keep it up.